That is set is something. Okay. Now there is a relation on S, which is A comma B comma C, and there are other terms also. Now, for this to be symmetric, there should be B comma A also for sure. That is, if if A comma B belongs to R, that is this relation, then B comma A should also belong to R for sure. It's a compulsion for it to be symmetric relationship. Okay. So we'll come to this again, understanding in the question. Coming to transitor. So what's transitor? There's A comma B belongs to R.
Sir, your screen is not visible, sir. Now it is okay.
So can you
Is it
give one
visible?
example for
Now it is okay,
symmetric
sir.
relationship?
Now it is visible.
हाँ,
So can you give one
हाँ, yes.
example for symmetric relationship?
Okay, we can. For example, this thing. Here, here snail frog is there, right? In this relation, it's on this. So this term is there. And for this to be symmetric, you need to also add frog, comma, snail. But this is not present here, right? It's not there. Snail, frog, bird, fox, frog, and snail, fox is there, right? This term is not there.
Yes,
Even
sir.
for this term, there should be fox, comma, snail, right? But that is also not present because of this terms not being present in this thing. R is not symmetric. Hmm. Now, uh, coming to transitive. If this term is there in relation, this term is also there, then A comma C, that is this back to this, should be in R. It's a compulsion for R to be transitive. So now we know the basic definitions. What
Sir,
is
in,
reflexive? Yes.
sir, in transitive, can other items also be present?
What do you mean by other items?
Like 1 and 2 are present, 2 and 3 are present, and 1 and 3 are also present.
1 and 2 are present, 2 and 1 are present, 3 and 1. But here
Yeah,
again, there is a problem. If you say like this, then 1 and 3 should also be present for it to transitive. But yes, it can be something like this. For example, this thing. 1, 2 is there, 2, 1 is there, 1, 1 is there. This
can
is
1 and 3
transitive.
be present also?
If 1 and 3 is present, then like this you mean,
Yeah.
right?
Will this
No,
still be
then
true?
no. No, but then 3 and 1 should also be present for it to be one.
In reflexive, if other items were present, then it was still valid. But in transitive, all elements will be
Yeah, and one more thing, look here. Here, this is A for suppose B, and C. Now, if 1 and 3 are present, then there should also be 2, comma 3. Then only it can be transitive. So you can't see that if other elements are present or not. You have to check whether the elements are present or not. You have to
and
check
same for
individually for
symmetric.
similarly for symmetric. For example, now 2, comma 3 is there, then 3, comma 2 should also be present for symmetric. And we'll get to know more about it with the question. So now solving the question. What is the question? Look, what are A and B? A and B are even non-zero integers, right? And so it should satisfy
Yes,
this
sir.
condition,
I'm
first
having
condition.
confusion in transitive relation.
Sorry, can you repeat?
Yes, sir. I'm having confusion in transitive relation.
Okay, what is it?
So actually, the elements which is required to us if the element present in set, except the other elements are also present in sets, then it transitive. It will be transitive or not.
For that, you have to check now whether the other elements are also satisfying the transitivity.
Means as you said in reflexive set, other elements are also present in reflexive. Still, it's reflexive. The
For
same condition
reflexive,
applied in
no, it doesn't.
transitive
It is
also.
not same for transitive and symmetric. It is only and only for reflexive.
Okay.
Because for transitive and symmetric, if you even add one term, one any other term, then you have to check whether it has. For symmetric, you will check whether it has this stuff. And for transitive, you will again check the other terms. If there is 3, comma 2 also, then 1, comma 2 should be present. This is there, and this should
Yes,
be
sir.
there.
Now
So
it's
it
clear.
depends.
Okay. Thank
So
you.
transitive and symmetric, you can't say that other elements can be present. You have to check each and every element. But for reflexive, yes, you only have to check that every element is mapped to itself. Let there be other terms, but this is reflexive. But it is not the same for transitive and symmetric. So here, A and B are even non-zero integers, and A by B is an integer. Because of and, both conditions together should be satisfied. Okay, so now let's check whether it's reflexive or not. For example, take B. Now let B also be equal to A. Okay. Now then, what will A by B be? Right? Is this correct? What does this mean? That every non-negative even integer will be mapped to itself. So because of this, it will be reflexive. Why? Because every not even non-zero integer will be mapped to itself. That is 1, comma 1, 2, comma 2, 3, comma 3. Not wait, only 2, comma 2 and 4, comma 4, and all the even non-zero integers. So yes, it's reflexive. Now coming to symmetric. Now taking symmetric relation, what we have to check is if A comma B is there, then B comma A should be in R, right? Now, for example, let's take A equals 4, B equals 2. Okay, both are even. Now, what is 4 by 2? That's 2, integer. So it's valid that 4 comma 2 will be present. But now coming to 2 comma 4 again. What will happen here is 2 by 4 give you fraction, which is not an integer. Can you please mute yourself?
படிப்பு முக்கியமா சாப்பாடு முக்கியமா?
Uh, Shanjana, like, can you please mute yourself? Thank you. So we were here 4 comma 2, A comma B, that is 4 comma 2, gives you an integer. But when checking for B comma A, it gives you a fraction, because of which it is not included, not
Sir, isn't
in
zero
R.
point 0.5 also an integer?
No, 0.5 is not an integer. No?
Oh, yeah, it's rational.
It's not an
Sorry.
integer. Right. So that's why it's not symmetric. Because if 4 comma 2 is there, 2 comma 4 should also be there. This is called counter example, which is establishing that this relation cannot be symmetric for this question. So think of this examples like that. And also be careful, like if what if I take 2 comma 1? 2 by 1 is integer, but 1 by 2 is not an integer. But here, what is the problem is 1 is not an even number. So be careful while taking examples. Try to fulfill all the conditions given in the question. When there is an and here. So that's why this question, the relation will not be symmetric. So this is false. Coming to transitivity. So now for this, let's tell that a comma b is present, okay, and a by b is integer. B comma c is also present, and b by c is integer, okay. Now what they are saying that then a comma then a comma c should also belong to R. But let's check. This is an integer, right? This is also an integer. Let's multiply them. A by b into b by c. Now multiplying it, b and b gets cancelled, correct? You will get a by c. And integer into integer will always give you an integer. So a by c is integer. A, B are even, B, C are even, then AC will also be compulsorily even. So if this and this, then this is present. What does this mean? Yes, it is correct. That R is transitive. So this one is correct. Now, what is an equivalence relation? Anyone knows that
Which is reflexive, symmetric, and transitive.
altogether? But we know it isn't symmetric, so this option is also wrong. Any doubt with this question? Only the question, not the concept. Anyone? Okay. With similar concepts, we'll do this question. Yes. So now this question. What is S here? Snail, fox, bird, right? Now what is R? Snail, frog, so good, fox, frog, snail, fox. Now they are asking for this three. Now again the same thing. For this to be reflexive, there should be snails, snail, fox, fox, bird, bird, and frog. But here only there is bird, bird. There is this is not present, this is not present. This is not present and this is not present. Meaning it is not reflexive. So this is wrong. Correct? Anyone doubt with reflexive?
No, sir.
Okay. Coming to symmetric. Now if snail frog is there, then there should be frog snail too, right?
This can't be symmetric also, sir.
Ah, everyone got this point. Even the other terms, fox, frog, they should be frog, fox.
Yes, sir.
So it's not symmetric also. And also the person who had doubt whether one element is sufficient for it to be reflexive. No, there should be every element mapped to itself. Here there is one element, bird, but it is not reflexive.
Sir, if it should be symmetry, it should be in the order of A, B, B, C, in that form, sir.
And the person, I was talking about the person who had doubt in reflexive. Someone was saying that, na, that if there is only any one term also, it can be reflexive, but no, there should be every term mapped to its of the set on which relation is defined.
For
Okay.
symmetric and transitive too.
Okay, now we'll check transitivity. So if snail frog is there, is there any term with starting with frog? No. So no, not to worry about this. Bird, bird. Is there any term starting with bird? Check for this term as the first term. Check for this term in the first place. Here. Here it should be there. This term. Every time. So similarly birds, there is none. Fox frog. Is there any starting with frog? No. What about snail fox? Yes, there is one. Snail fox, fox frog. If snail fox is present and fox frog is present, then there should also be snail comma frog, and it's there here, right? So hence that's why it's transitive. Any problem with transitivity?
No, sir.
Everyone?
Can you tell
Everyone?
about transitive again?
Sure, I will. Now, for example, here, check for terms like, is there frog anywhere in the first term? Here, or else here, also. No, right? So we don't
No.
need to check transitivity for this term. Leave it. Go to next term. Checking for this. Is there any term starting from bird?
Yes, current one.
Correct one. But it is again, if there is bird, bird, for example, B for bird, then bird, 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 bird. Then they should be
Sir,
bird.
for
But these all
transitive,
are
it
the
should be
same.
only in pairs. Am I right?
Sorry, can you repeat?
For transitive, it should be only in pairs.
Huh. For the same terms, like something like this, you don't check transitivity because it is transitive to itself.
Is every reflexive function transitive also?
No, can't say that because you also need to check what other terms are present. Because, for example, if you take this snail, fox, fox, bird, bird, frog, frog. Okay. Here, if you check this, yes, this relation is reflexive and even transitive. But what if there is one more term? It's also symmetric. Yes. For example, there is but only till now. Now, if we have this term, now this is reflexive, okay, but it is not symmetric. Is it transitive? Why? Yes. So frog, 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 snake, then frog, snail also is present. So it's already present. See, it's just transitive. So this thing you have checked it manually. So for symmetric transitive, you need to check every term. And reflexive relation is symmetric and transitive when there is no term like no other term. Then it will be an equivalence relation. But you need to check because this is also reflexive. And if there is any other term, then also it's reflexive. But again, because of this other term, you need to check this and this. So you can't say that reflexive relation is wrong. There's no relation between them. They are independent, especially this two, because you have to check every term in this two.
So is every symmetric function transitive also?
Every symmetric.
Yeah.
Uh, Symmetric, let's take like this. Now, for example, this is symmetric. No, it's not symmetric. There should also be this. So yes, this is symmetric, and it's also yes, you can say that every symmetric relation would be transitive. But I am not sure to prove if it's true for every time, but most of the times it would be. But be careful of the other terms, like the individual terms.
But if extra terms are also there, then it wouldn't be symmetric in the first place.
Right. But I'm not. Most probably, yes, symmetric relations are by default transitive, but I'm not sure if it's true or not completely. Mm, mm. Why is it? It's symmetric for sure. Um, okay, you have found the counter example. Yes. So the person who was asking that every symmetric relation is transitive, no, it isn't. One of your mates have given the counter example. For example, this.
Yes.
Uh, this is symmetric, but it's not transitive. So they are independent for sure. You need to check each and every element manually for symmetric and transitivity. Manually, or else prove it in this way. The question which we did in the last, this one. Here we argued with variables. Here there were no definite values, so we used variables. And here we have definite values. So it's not reflexive, it's not symmetric, it's transitive. So now continuing with the same thing, no, we'll do this later.
Sir, can you start week two tomorrow?
Can you be louder, please?
Can you start week two from tomorrow?
Okay, if no one needs week one, then yes, we will start
No,
week
sir.
two by tomorrow.
No, I'm asking today you will take week one and tomorrow we can start from week two.
It depends. It depends on you if you want it or not.
Sir, is it
And
possible
I
we
am
can
also
take
not sure when
recording
are the
of this
classes.
session by
Okay.
tomorrow?
No, probably no,
Sir,
probably
I have
no.
doubt. How will they take attendance?
I don't know that. I even don't didn't know that there is a session now.
Sir, because in the
That's why I
mail
was late.
they gave if we have only attendance of 60%, they will refund 1,000 rupees. So that's why I'm asking how they will take the attendance.
Okay. I need to check with the instructor.
Okay.
By next session, I will let you know. I'll let you know all this doubts, attendance, recording, the time. No, timings is almost this one only. But which days the classes will be and for how much duration?
In Gmail, in
Can
the
you tell
mail,
us
it was
which
written Saturday,
days
Sunday,
were
and
late?
Wednesday.
In mail it was written.
It in email we received, it was written Saturday, Sunday, and Wednesday.
Okay, Saturday, Sunday, and Wednesday. Okay.
Yeah, and timing was 7 to 9.
Okay, so 2 hours daily. Okay. Okay. This timings most probably will be the same, but about attendance and the schedule, I'll let you know in the next session.
Sir, actually, sir, I'm suitable to take class 7 to 9 p.m. The time will be changed for other days like Monday, Tuesday.
Most probably no. Maybe you would have some feature that helps you change the timings. Okay, I'll let you know about this too. About like the change in
Sir,
timings.
the one thing is confirm about recording session because sometimes we got lost our network.
Ah,
Then
yes,
we will not.
attendance, recording, and the timings. I'll mark that. Attendance, recording, and change in timings.
Thank you, sir.
Right. I'll let you know all of this my next session. And not even in session, then on the G space. So continuing with the question. what is the minimum number of elements of the Cartesian product S cross S that need to be added to R such that relation becomes symmetric? Okay. Now we already know that it is not symmetric, right?
Yes, sir.
So now for this, there should be this, right? So we added one term for now. For this, nothing to add. For this, I add one more term. So till now we add two terms. And for now it's symmetric. Checking for snail, fox. You add fox over snail. So we know this was already we added this three terms. So what is the minimum number? That is this three terms. So three is the minimum number to make this relation symmetric. Is that fine?
Yes, sir.
Anyone, any doubts in reflexive, symmetric, and transitive? Anyone?
Excuse me, sir. Can you just repeat the last one? What you did say, sir?
This question, right? The symmetric one. Make it
Yes.
symmetric. Okay. Can you say me that what is symmetric relation? Like for the example you have taken, if A comma B is in R, then what?
Symmetric A comma B should be in relationship and B comma A also present in relation.
Right. So we know this. So here you see snail frog. Is there frog snail in the relation here? No, right?
Yes.
So I add this term. So for now the count is one. Now this is symmetric to itself, so no need to add any. For this term, is there frog and fox here? Frog comma fox, no, right? So I add one more term. So now the count is two. Similarly for snail comma fox, there isn't fox comma snail, so I add this third term. So now it's three. So in total, how many minimum elements did I add? Three to make this thing symmetric. I can still add this all, comma fox, fox, comma full. It will still be symmetric. But they ask for minimum. Here they ask for minimum. So minimum is three. Is that fine?
Yes, sir. Now it's clear. Thank you, sir.
So anyone, anything else with reflexive symmetric transitive?
No, sir.
So anyone who has doubt in cardinalities? Huh?
No, sir.
Yes.
I have one doubt
Uh,
actually.
yes.
If the set is a set of rational numbers, then how to find its cardinality?
What was that? Rational or real?
Yes, yes.
Any one
Rational
of them,
numbers.
right?
Yeah,
Okay,
any one of them. Let's
for
say it's
example,
between
rational.
1 to 100, the rational number range. Then what is the cardinality?
This is set of rational numbers. Okay, right?
Yes, sir.
Now we are asking to find its cardinality, right?
Yeah.
So first of all, its cardinality. There is something called degrees of infinity, and you even have extra sessions on it, right? On the lectures by professors. Did you like? Do you know them or did you watch them?
No, sir.
Once go watch them because that will give you better understanding. Because there are like types of infinity, countable, uncountable, and this its cardinality is not finite. So you can't give it a number. But in this session, you will know that how do we represent its cardinality. Okay, so check that out. And it's not in any exam or anything. It's not graded. Those lectures are just for extra info.
One of such questions was in
Okay.
the GA for week one.
Such question. They won't ask cardinality of rational numbers.
No, there were the question was like there were three sets, and one of them uh, was a set of rational numbers, and we had to find the cardinality of one set. For example, a minus b.
We will discuss it in next session because it's a GA question. Most probably, no, they won't because a set of rational number doesn't have finite cardinality. Specifically, I
Yes.
was talking about set of rational numbers, not about the question.
No, no.
Excuse me, sir.
Okay.
So,
Now coming to
excuse me, sir.
okay, so maybe cardinality is like good to all of you, right?
Yes.
Okay.
Excuse me,
Anyone,
sir.
any
I'm
particular
audible.
concept?
Sir,
Yes,
functions.
yes, functions and the other person who was talking.
Bijectiveness.
Okay. Okay, so functions.
Sir, give me the definition for functions, sir.
Okay. Okay, first with functions. So function is mapping of one set to another. With some constraints. So for example, if I say f is defined from A to B, okay? Now there are some elements in A. Let it be random things. Okay. Now what is the thing like? For example, there is this thing. What do you think? Is this a function? Is this a function?
No, sir.
No, sir.
The person who asked out, the person who asked out, is it a function?
No, sir.
Why?
Sir, because same input can't have two output.
So that's the only definition of function. That every element in domain should be mapped exactly to one element in codomain. This is domain. This is codomain. So this is the basic definition of function. And there is something called vertical line test. For example, if you aren't given a function, its set or anything, and if you are given its graph, uh, something like this, okay? And there is another function, something like this, okay? Now, what's the difference? If you do
Sir,
vertical
this
line,
is week 3 only, no, sir. This part.
sorry,
Polynomial. No, what you are doing the graphic part, no, sir. It's from week 3
This
only.
is a random graph. I don't know which equation it is. I'm just telling that how do you identify if a graph is representing a function or not. Okay. So for here, if you do vertical lines, that is, this is one input, then it should only cut the graph equation at one point. So this is valid. This is valid. But here you can see it's cutting at 3 points. That is, one input is mapped to three outputs. Vi, Vi, J, and Vk. Okay. But this is not a function then, because one input has three outputs here as per the graph. So this graph does not represent a function. So this is not a function. And now similarly, here you can see that every vertical line will cut the graph at only exactly one point. Okay. So this is a function. This is called vertical line test. You have to check whether the every vertical line is intersecting the graph equation at exactly one point. Then it's a function. Else it is not. So this was the definition of function. Now coming to onto onto and bijective functions. Anyone who knows one or into function, please see.
Sir, what is mean by range? It means result only, sir, if I'm not wrong.
So let's first talk about one. For example, there is this equation 2x plus 5. Okay. Now it's intercept is 5 and its slope is 2. This is the equation. Now what does it say? It is so here you can see that we know this thing. No? This is a function, right? This is a function.
Yes, sir.
Yes or no? Okay.
Yes, sir.
Is it 1 1?
Yes, it's a
No, sir.
function.
Okay. Okay. Now let's see why it's not 1 1. Now here you can see that here it's two inputs giving us same output. That is, now we come to horizontal axis. There is this graph. For example, let it be parabola. Okay. Simple f of x equals x squared parabola. Okay. Now you see there are two different outputs at -2 and 2. Both f of -2 equals f of 2 equals 4, right? Is this correct for this? Yes or
Yes,
no?
sir.
Everyone. Everyone. So
Sir,
here
how
what
they
is
are
happening
minus
is
4? Is it minus 4 or equal to 4, sir?
4 4 4. This
Equal to
is
4.
equal. Yeah, equal
Okay,
to 4.
okay, okay.
So at two different input is giving same output, right? So this is not 1 1. What is 1 1? 1 1 is Now you have this. So this whole thing, this will have exactly only one mapping. It can't have two inward arrows. Everything in this B part should only have one arrow. It can't have two arrows. That is, two different inputs or three different inputs cannot give the same output. These are output values. These are input values. Domain, codomain. Okay. So for 1 1, what do they say? Oh, we call A2 is pre-image of B3. This is the term. So what do we say? Element in codomain has exactly one pre-image. Anyone who's facing problem in this thing?
No, sir, but
Anyone?
how to find
Okay.
if a function is 1 1?
That will come to it. But now we know the definition of one word, right?
Yes, sir.
So coming to that one word, if it is one word or not. Here they are asking to check if it is one one or not. That is injective. Okay. Now let's take there are two different outputs, inputs x1 and x2. Okay. We are assuming that assume x1 not equal to x2. Okay. Is this fine? Everyone?
Sorry, can you please
Yes,
repeat?
sir.
Here I am taking two different inputs, x1 and x2, and assuming they are different, meaning they are not equal. Okay. And I'm equating the outputs. Here I'm trying to prove that this is not one one, that it has two different inputs and same output. Okay.
Yes, sir.
So now for this to be equal, this will also be equal, right? Now 10 and 10 gets cancelled. Multiply minus 1 both sides, you'll get x1 equals x2. But what did we assume? We assumed x1 is not equal to x2, which is a contradiction, right? Hence,
Sir, first of all, how to solve these kind of problems, sir? Should we equal it or how to do, sir?
this like this only. Think that there are two different inputs, equate the outputs. Output is root of 10 minus the input, right? So here I did the same thing. What did I do? I equated the outputs and assumed that the inputs are different. But while equating and simplifying it, I got that the inputs are same, which is a contradiction. That is, it's opposite, right? What I assumed and what I get. If you get like this, it's 1 1.
So if you
And if
assume
you
inputs
get the
are not
same
same,
thing,
but at the end inputs are same, that means it's one function. Is it correct?
yeah, because at the end, what did you assume? We assumed they are different. But what did we get? We got that they are same.
Yes, sir.
That's why it's 1 1. For example, now, if we take this thing, there is a function x squared plus 2. Okay. Now, what I will try? I will try the same thing. Now, assume x1 not equal to x2. Okay. 2 gets cancelled. X1 square equals x2 square. Now, you can clearly see that because of square, inside thing can be negative or positive. That is, 2 square equals 2 square. 2 square equals minus 2 square. So here you can see for we found one case where x1 is not equal to x2, right? What we assume is correct. So this is not 1 1. Is this fine? You'll check similarly with the others. For example, let's
Sir, can you solve f of x equal to 2x plus 9?
oh sure, I will do that. So now to is this fine? Correct? Understood till now, right? Now 9 and 9 gets cancelled. 2x1 equals 2x2. X1 equals x2. But what did we assume earlier? X1 should not be equal to x2,
Yes,
right? But we got this. So this is 1 1. That's why it's correct.
Okay, sir.
Now, anyone would volunteer for the second equation? Like, can they say these steps? Try to say these steps. Let it be wrong or correct, anything.
Yes,
Anyone?
sir, it's 1 1. The second one.
But, like, how? How did you prove it? You
The
proved it just
3x and 3x get cancelled. The 6 gets
no, no, no,
subtracted.
no. Wait. You can't cancel x1 and x2 because we assume that x1 is not equal to x2. So just cancel 3, okay?
Yes,
Now what you will do, multiply this x2 here and this x1 here. So 7x1 x2 plus 6x2 equals 7x1 x2 plus 6x2. So now we know that whether it is different or same, these two terms will be same.
yes, sir.
So we cancel them. Now what it is? 6x2 equals 6x1. Divide by 6, you will get x1 equals x2. Contradiction. Hence, it's 1 1. You can't cancel them, huh? You can't cancel x1, x2 anytime because
Because they
we
are
have,
different.
they are different. So now we know what is 1 1. Now we will go to what is onto. Onto and then bijective. Bijective is nothing. Anyone knows what is bijective?
Which is both 1 1 and
Both.
onto.
Sir, how
Yes,
to find
it should.
on to, sir? Subjective interval.
That only we are going to do now. So onto. What does onto mean? For example, we'll take numbers right now for better understanding. Now there is this 2, 3, 4, 5, 6. Okay, this is A, this is B. Now, can you say me that every element in B has a pre-image in A? Yes or no?
Yes, sir.
No, 5 and
6 is
6
left.
do not. Even 5 is left.
Yeah.
So this is not onto. What is onto? In 1 1, what did we say? We said that every element, not every, the element in codomain should have its pre-image, right? Only one pre-image. Now what are we saying? That every should have at least, and every are some new ones in onto. In onto, we need every element to have a pre-image and that to at least one. There can't be zero. This to have zero pre-image. they should have one pre. So what? Okay, let's take some question. Let's take this. One minute, huh? Now this question. Now we'll first check on two and then one. Now when n is odd, when n is odd, if you add one, what it will become? It will become even. Yes or no?
Yes, sir.
So if even number is divided by two, it will still be a natural number because natural is natural, right? So when n equals one, f of one equals one. N equals two, f of two equals sorry, one. Now here one more thing. Two different inputs but same out. So what it is not one one. So these two options are eliminated. Not one one, not one. Now checking for one. What is the codomain here? Natural numbers,
Natural
meaning
numbers.
it would be one, two, three, so on, right? So here one. Now but n equals two, f of two will be equal to three. F of three equals two. N equals four, then f of four will also be equal to two. So one has two pre-image. That is at least one pre-image is satisfied. Now two also has two pre-images. Now checking for any natural number x be a natural number. So it will always have a pre-image. Why? Because even if you go further, there's a pattern. So one has pre-image, two has pre-image, three has pre-image. Every natural number, that is every element in codomain, what is codomain natural number, will have a pre-image, at least one pre-image. Hence, it is onto. So F is onto, but not one one. Anyone, any doubts in onto? Onto is
Like
also known as surgeon. Yes.
so, like you showed a way to find one function. Can you do the same for onto?
Um, we can't. Onto you have to check. For onto, there is a condition that is range is equal to codomain. Codomain is this thing. This is codomain. And what is range? F of
It is
Actual
sir.
set of numbers used in codomain.
for all the inputs, there should be like there will be some element in codomain, no? So that all should be there in the range. So this and this should be equal. Range is set of outputs. This is also set, but it is not necessarily equal to set of outputs, meaning that it can have this too. But now, if I say there is A1, A2, AN, this is mapped to this is mapped to this is mapped to some other element, this is left out. So here range is B1, B3, so on, but codomain is B1, B2. Because of this one thing also, it is not correct. So you have to, for onto, you have to check for range equal to codomain. Any doubts on you?
So we have to manually check it.
Huh. You have to manually check. You have to get, like, for example, we find domain, we find range, right? So you have to find range, and if it equates to codomain, then it's onto, and if it doesn't equate to codomain, then it's not on.
Can you please solve one example?
Yes. Let's do this. Okay. Here, what is the codomain? It's set of integers, right?
Integers.
Okay. Now let's take this only. Let's check. It is either this equation or else this, right? Here you can see it's this or this, right?
Yes, sir.
And what is B? B belongs to integers, right? So if there is an integer x plus b equals to some output, let output be y. If this is an integer, then this will also be an integer. Yes or no?
Yes, sir.
Yes. So for every integer y, there would be some kind. X is varying now. So let it be any integer. Then x, this thing, will be equal to y minus b. So x will always have a value. Y will always have a pre-image. You can check it this way, or else for simple functions like this, what you can do is make a graph. Now you know that at some value of integer, it would be an integer. Something like this, right? For this one, because it's -1 slope, right?
Yes, sir.
Anyone else, like anyone facing any trouble? Okay. So every integer is coming here. And this will go till this will go along till minus infinity and plus infinity. So here all integers are getting mapped to one output at least. So that's why this is onto. And similarly, you can see every input has exactly one output. So it's into also, or you can say 1 1. Hence, this is bijective. Here they ask for bijective. Anyone still any doubts with bijective onto into?
No, sir.
Any more examples?
Sir, I didn't hear this one example. The last one.
This one? Okay, let's do fourth option. Why it is not bijective? You mean that only, right? Now, for example, let a be all integers but not 0. Okay. So then the equation would be like this, or else like this, any slope line, but it won't be flat. It won't be parallel to x-axis because I didn't take a. a to be 0. So if this option was something like this, b equals 0, a is equals to z, such that z belongs to z minus 0, then this would be correct option. This is correct. But this is not correct because when a is equal to 0, then f of x would always be 0, which is x-axis itself is the plot, this thing. It is horizontal. And if it is horizontal, every input will give only one output. So it is not 1, 1, right?
Yes.
And it is not onto also because range is only 0 and codomain is integers. So they are not equal. So this is wrong. Just because when a equals 0 is not satisfying. Anything else?
No, sir.
Sir, what is equivalence class?
Equivalence class is not necessary. It won't come for this course.
It was in one of the activity questions.
Um, okay, then I'll let you know about it in the next session.
Okay, sir.
Or else I will like discuss it on the G space. Who asked it?
Aviral.
Okay, okay. Anything
Sir,
with set relation? Yes.
can I leave the class?
Yes, you may leave because I don't know even
Excuse me,
what
sir.
the attendance process is right now. So you may leave.
Okay, sir.
And
Thanks, sir.
anyways, we will be ending in by 8:45.
Okay, then I'll
8:45
stay.
or 9.
It's okay. I'll stay, sir.
Anyone, any concept? Okay.
Yes, sir.
Any
Uh,
specific concept?
yes, sir, I have one. How to find domain, codomain, and range?
Wait, codomain is already given. Okay, like codomain is this thing only. Now, if you want to find valid domain, how would you find that? Okay.
And range also.
Mm. Range also. Let's do this for domain first. So here, for this to be valid, this thing should be positive, right?
Yes, sir.
Yes or no? Yeah. So 14 minus should be greater than equal to 0, right?
Yes, sir.
So open the brackets. You will get okay. Now let's like make the denominator common. So it would be 56 minus 12x minus 35 plus 5x by 4 greater than equal to 0. So for this to be greater than equal to 0, only this thing can be greater than equal to 0. So we don't need the 4 now. So we will just like multiply 4 both sides. We can multiply positive numbers only, no negative numbers while solving inequalities like this. So here now what we will do, simplify it. You will get 56 minus 35, that is 21, right? 21 minus 7x greater than or equal to 0. Now what is x? X 7x is less than equal to 21. So X is less than equal to 3. Less than equal to 3 meaning it would be this. And that's the answer over here. This is for the domain. Okay.
So after 56, how this 12 has come?
Your voice is not clear. Can you repeat?
Sir, I'm saying after this 56, how the 12 has come? I'm just confused with one.
After this, what? Can anyone understand it?
56.
There are 20 minutes. Like it's 7 to 9, right?
Sir, I'm saying after this 56, how this 12x come? I didn't get this one. Line. Third line.
Okay, wait. Okay,
There is
okay,
some
okay. The simplification. Okay. Here, you can see it was 14x. I multiplied 4. 14 into 4 is 56, and
yes, sir.
minus 3x into 4 will be minus 12x. So here is that thing. And here I just like plus taken inside, and denominator was 4, but I multiplied both side with 4. And 4 into 0, the other side would be 0. So till here is fine. Now, what is 56 minus 35? It's 21. What is minus 12x plus 5x? It will be x of minus 12 plus 5, minus 7x, right?
Yes, sir.
So minus 7x.
I'm just confusing third one
I
now. Thank you, sir.
Right. Anyone with any specific concept?
How to find range?
Hurry. Let's find range of this function itself. So here, what is the root value gives?
That
It
the
always
result
gives
will be
positive.
either positive or negative.
The inside part will be positive, but it
Yeah.
also gives always positive output, right?
Like outside the root isn't, don't we add the plus minus sign?
No, we usually don't. We always go with the plus sign only. Here for this one. In general, all questions, whatever the root is, except the quadratic formula.
Got it.
So here, also we know that at 3, what is the value? It will be 9, 35 minus 15 by 4, right? 35 minus 15 is anyone? Hello, can anyone solve this?
14 minus
Only
5.
the guy. Sorry?
14 minus 5. Uh, will
4.
9. 9 will be the answer.
Wait, can you repeat?
9 will be the answer.
How 9? How
20
much is
by 4
this?
is 5.
It's 20.
Sorry, sorry,
20
10,
by
10,
4,
10. 10 will be the
right?
answer, sir. Yeah.
Huh. So 10 is the answer. And now, so we got root 10 at what? At value 3, right? But wait, there is some mistake. Wait, it's 9 plus 5 now? Yes. So 9 plus 5. This is 20 by 5.
Yeah.
This is 14 minus 9 plus 10. So this is equal to 14 minus 14, which is equal to 0. So the minimum output which is just giving us 0, and then all the positive values till minus infinity. So the range of this function will be 0 to infinity. So most of the times while finding range, what you should do is to find minimum or maximum value of the function. For example, here this was the domain, right? What I did, I took the extreme values, that is 3, and I tried calculating the value at 3. So at f of 3, it equals 0. Now anything less than 3, you can clearly see, like for example, let's take 4. 14 minus 3 fours are 12 plus 35 minus 5 fours of 20 by 4. 14 minus 12 plus 15 by 4, right? So 14 minus 12 minus 15 by 4. What is this? 14 minus 12 is 2. 2 minus 15 by 4. Again, some addition mistake. 5 fours are 3. Okay. This is 15 by 4. So this shouldn't be greater than 2. Okay, wait, 4 is okay. Let's take 2. 4 is out of the domain. Look, this is correct one. So 12 minus 15 by 4. Now you can see here that's 2 minus 15 by 4. If you calculate this, this is negative, right? Which is out of the domain. That is 4 was out of the domain. That's why it is not giving the correct output. It is not real out. So 4 is out of the domain. Now if you take for example 2, what will 2 be? It will be 14 minus 6 plus 35 minus it's 5x. So 2 10 minus 10 by 4. 14 minus 6. This thing will be 25 by 4. So minus 25 by 4. So this will be 8 minus 25 by 4. 32 minus 25 by 4, which equals 7 by 4, which is a positive value. So it's in low. So from 0, it came to 7 by 4 as we moved from 3 to 2 in between. So the value is increasing. So at minus infinity, it will go to plus infinity, f of x. That is, x goes to minus infinity, then f of x will go to plus infinity. So the range is 0 comma infinity. Hopefully now you got that why like how to find the range.
Yes, sir. And codomain.
And codomain is nothing. You have to check the function on which set it is defined. For example, here it's defined from natural number to natural number. No? So natural number is codomain.
Like,
And
if let's say natural number is not given and we have to find it.
you can't find it. Codomain would always be given.
Got it.
Codomain is always given. You have to find range. And as you find range, you will compare them. You will find onto. And before that, you will do this assuming x1 not equal to x2. This you will assume and try equating and evaluating to check for on one into 1 1, right? So
Correct, sir.
codomain will always be given. You will only have to find range for checking onto, and for into you have to just do this x1 x2 thing, and for bijective you have to check both into and onto. So that's the thing. So we completed basic definition of function, into and onto functions, bijective functions.
Sir, I
The
want to
system,
ask one thing.
yes.
So tomorrow will you show more examples on these things, the domain and this one? Because I have today doubt is clear, but I think I need more practice. And if you show 2 3 more questions tomorrow, it will be helpful.
Okay, then next session I would suggest you all to practice questions yourself, and the questions which you can't solve, list them out and ask them. So if, like, everyone will not feel like bored, because I feel that none of us are interactive, right? So from next session I'll plan it well, and before that try to practice the questions, the activity questions and practice questions of week one, and whichever questions you can't solve,
Sir,
ask
I am
them.
audible.
Okay, sir.
Yes, you are.
Sir, 2 3 questions you can discuss after that, right?
Sir,
We
I am,
can.
sir, I
Okay,
have
sir.
Yes.
confusion in Venn diagram. Can you just elaborate little bit? In graded assignment, one question, I just confused.
Okay.
Like,
First of all, what is this region?
A. Set A.
A. So all elements present in A. Or else let's take this question itself. We'll do Venn diagram completely with this question. Yes. Here they are given maths, physics, and statistics Venn diagrams. Okay. And they have, yeah. And we have to solve for the options. So here, what is the first option? The set of student who take both math and statistics. D is here, right? The person who asked out specially. D is here, right? So you can see that this region is for people who took math and physics. It's
so,
not statistics. So this is wrong.
excuse me, sir.
Okay.
Hello.
So first option is wrong. The second option, D, E.
Sir,
So D, yes.
sir, I can solve this small question. I'm just confused if the question digits are large. Like in graded assignment, one question is there related to animals, like how many Bengal tigers.
The tiger one.
Yes, that one. I'm confused in that one question. This one question is
Uh,
like,
I can't discuss that Tiger question because still the deadline is not completed. But I'll do this question now. Not this. Wait, 1 minute. This question is written. So here you can see this, right? What is N of television union radio? The cardinality. What here is the statement? An advertising agency finds that of its 200 clients who use television or radio or both. So N of TV union radio will be 200. That is, this whole region will contain 200 elements. This whole, both the circles. And what is 150? 150 use television. So people who use television are this, right? So this is TV, 150. Now, what are they asking for? How many use only radio, right? Only radio, meaning we need this region, right? What is it? It is N of TV union radio minus N of TV equals N of radio minus TV intersection radio. This thing is notation for this yellow region. This is the multicolor region, and this is the whole thing, both the circles together, both regions together, both multicolored and yellow. So complete region minus the multicolored region will give you yellow. So complete region has 200 elements minus television has 150 elements. This will give you 50. Even the Bengal tiger thing, if you try to create Venn diagrams, there are actually four more sets, right?
Actually,
There is
sir, I
male,
can
female, and
solve this one
also
question, but
Bengal white tigers and Bengal royal tigers.
sir, is it
So
possible we can
yes,
solve in next session one graded assignment question? Because I can solve this one as well. I'm just confused only that one question.
then we will solve it after the deadline comes in the next session.
Yes, sir,
Sir,
I'm saying the same thing. We can solve next one session.
sir, one last
Yeah.
question. How to find cardinality?
For finding cardinality, first of all, the set should be finite. Okay. So we'll do that in this question. This one was there, right? Snail, frog, bird, bird, fox, frog, snail, frog. Now, what is the cardinality of S?
4.
Okay. What is the cardinality of S cross S?
16.
Now, what have they asked here? Let P be a subset of S cross S minus R. What is the set of possible cardinalities of P? So, uh, S cross S we have, and we are removing this four. We are removing this four elements, right? From R, from S cross S, right? So it is snail, 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 fox, snail, bird, snail, frog, right? Similarly with fox, this is I'm writing S crosses. Similarly with fox, it will be fox, snail, one, two, three. So there are total 16 here, and which we are removing snail frog. Snail frog is here, bird, bird. So here it's bird, snail, bird, fox, bird, bird. So we are removing this thing. What are we removing else? Fox, frog. So fox, frog, fox, 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 bird, fox, frog. So fox, frog, we are removing. Now what is the fourth? Snail and fox. So this four. So remaining how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12. Now what
So
have they
we should
asked?
count
They
it
have,
manually.
we can just count it manually. Most of the times you have to count it manually. And here you could directly see that this 16 elements and this 4 elements, you can directly do this 16 minus 4. because you know this R is subset of this. You can directly subtract it, you will get 12. You did not need to do this. So after getting 12, you are finding subset of this. So subset of this can have 0, like even empty set is subset, right? So it can have 0 elements starting from 0. It can have any one element, snail, snail. It can have any 2, 3, 4, and so on up till it can have all the elements together except this 4 because we have subtracted them. So it can go from 0 to 12. So here you are so here you are calculating cardinality like this. And most of the times you have to do it manually. There is no trick like the injectable. Anything else? Anyone? No, you aren't. Can you speak again? Yes, I'll do that. I'll do that on the G space. Anything else? Anyone?
So could you please refer some books related to this session or related to our exam?
Then I would say the books which are there in supplementary content. And I will even send the link in the G